Hey guys, it's time to go over section 2 of our classification of matter chapter. So section 2 talks about the properties of matter. So we're going to be going over the difference between physical properties and chemical properties, and then the difference between physical changes and chemical changes. So we're going to start with properties, and specifically physical properties. And physical properties are any characteristics of something that you can observe without changing the identity of the substance. So some examples of physical properties are things like color, shape, size, density, melting point, and boiling point. I can observe those things without making any changes to the object that I'm observing. So this is a good example of physical properties. If you were just to describe this basketball, you would probably begin by saying that it's a sphere, it's orange, maybe that it's a solid, that it has black stripes, things like that. All of those things are physical properties, okay, of the basketball, because I can observe them without making any changes to the basketball. You could also measure physical properties as well. I could measure the mass of this basketball, and that would be a property of it. Or the example on the screen right now is that you could measure the diameter of the basketball. That would be another physical property. Some other physical properties may describe the behavior of the material, and that would be things like magnetism. So attraction to a magnet is actually a physical property because we can observe magnetism without making any changes to the metal. All we have to do is try it with a magnet. And a lot of times, physical properties are great ways to separate mixtures. In fact, the best ways to separate mixtures are to figure out the physical properties of each substance in the mixture, and then use those properties to separate the mixture. So size is one physical property that's often used to separate them, like when you pick off the onions off of your pizza, or you decide you don't want green peppers on your pizza. You pick those off because they have a specific color, they have a specific size, specific shape. So I'm using physical properties to separate them off of my pizza because I don't care for green peppers on my pizza. So for instance, if you had this mixture, it's a mixture of iron filings and sand, and in this case those particles are approximately the same size, so I couldn't go through with my hands and pick out the iron pieces because they're like dust. So instead, what you can do is figure out that iron is actually magnetic, and then all you have to do to separate the mixture is take a magnet and run it through that mixture, and all of a sudden your iron is separated from the sand. So you've used a physical property to separate the mixture. So the magnet would only attract the iron and would leave the sand behind. So this is a really good example of using a physical property. In this case, it's magnetism, or the attraction to a magnet, to separate substances in a mixture. So since we've talked about physical properties, now we're going to go ahead and talk about physical changes. And those are any changes in size, shape, or state of matter. So any changes that do not result in an identity change of whatever you're talking about. So the kind of substance, in other words, the identity of whatever you're looking at, does not change. So I'll give you some examples. This picture shows a physical change in iron. Color changes are a physical change because if I take a piece of paper and it's white and all of a sudden I color the whole thing purple, it is still paper. So that means all I did was a physical change, because even though the color has changed, the substance itself is still the same. And that's the definition of a physical change. The one that you see right here is a physical change in iron when it is heated. When you start to heat iron, it glows this orange color, which is a physical change, a color change. And eventually, if you heat it to very high temperatures, before it melts, it will actually turn white. So that's 2 physical changes before the final physical change of turning to a liquid, which once again is physical because even though it went from a solid to a liquid, it is still iron. So if at the end of the change you can say to yourself, is it still iron? And you answer yes, then it is a physical change. Whatever the substance may be, it may not be iron. So if you can say, is the substance still what it was before the change, then it's a physical change. Another example of a physical change is the separation of salt water. So what you want to do is separate the water from the salt. Like if you live by the ocean, it just makes sense kind of to try to use salt water as your source of water. So one way that we can separate salt from water is to use a separation technique called distillation. And the property that it uses is boiling point. Okay, that's a physical property because I don't have to change the substance in order to observe it. And this is what a distillation apparatus actually looks like. The substance that you're trying to separate is going to go in this flask right here, and you're going to heat it until the aspect of the mixture that has the lowest boiling point actually boils and moves up here. And then you have this condensing tube, so this substance is going to condense, turn back to liquid, and then it will fall out into this tube. So you'll end up with your mixture separated. Half of it will remain in this flask, and then the other half will be here, and you will have separated it. Okay. Now that we've talked about physical properties and physical changes, now we're going to talk about chemical properties and changes. So first, we're going to talk about chemical properties, which is a characteristics of a substance that indicates whether it can undergo a certain change. Examples of chemical properties, one of them is flammability. Another one would be reactivity. So chemical properties can only be observed when a change in the substance happens. So because if I burn something, if it's flammable, I can only observe that by burning it, and that would change it to something totally new. So in order for a chemical change to have occurred, the substance before has to change into something else. So the exact opposite of a physical change. In a chemical change, you end up with something completely new and different from what you started with. So an example that I have here is when you drop like Alka-Seltzer in water. Beforehand, I had water in Alka-Seltzer, and afterwards, I have a completely different substance. I don't have the same starting materials that I had. And so that indicates chemical change. A sign that a chemical change was occurring throughout that process would be the bubbles and the fizzing. Some other signs that a chemical change is occurring would be things like heat being produced, things cooling down, if you see bubbles or all of a sudden there's a solid that wasn't there before, especially in a liquid, then those are helpful indicators that a chemical change is happening. But the only sure way to know that it is a chemical change is if a new substance is produced. And sometimes those clues are really small. Like iron, the only clue that iron has changed into a new substance is the presence of rust. And sometimes that's hard to see. But burning and rusting are chemical changes because after that change occurs, a new substance has formed. It's no longer iron once it's over. So just a quick chart to help recap the difference between chemical properties and physical properties. For chemical properties, they can only be observed when the substance is changed into a new substance. Things like flammability and reactivity. If you are observing something's flammability, it has caught on fire, and therefore at the end of that change it will be something different. So that's definitely a chemical property. Physical properties can only be observed or measured without changing the substance's identity. So those are things that you can It's kind of like when you observe them with your senses. If you can see it, if you can touch it, if you can hear it, things like that. So, physical properties are things like color, size, shape, state of matter, but they can also be measured. So it's also things like density and boiling point and melting point, because any of those examples that I said do not change the substance at all. I can take all those measurements and make all those observations about a sheet of paper without changing anything about that sheet of paper. It will still be paper when I'm done observing those properties. So, our final wrap up of this section, which is the final section of this chapter actually, the quickest way to show the difference between chemical change and physical change. If it's a chemical change, a new substance is formed. So in other words, the substance that you started with is gone. It's no longer there. You cannot get it back. In a physical change, the substance's identity does not change. So if you have observed a physical change, and we'll say that it is ice melting. That's one that people get confused all the time. But if I asked you what ice is, you would say water. And if I pointed to a glass of water and said, what is that? You would say water. So actually, even ice melting is a physical change because I started off with water and ended up with water, even though it looks different. So the substance's identity does not change. That's the difference between a physical change and a chemical change. If what you started with is still there, it is physical. All right. That ends this chapter, actually. So I will be sending out some practice going over physical and chemical changes, and then either next Tuesday, or I may combo it in on Thursday's release. I'll send out something that kind of goes over this chapter as a whole, and then we'll start a new one. So I will talk to you soon.